R&D projects related to nanogeosciences. So they did their research, they applied all those in the field area, and then it was manifested in their positions. We all know the success exploration story of China. They are almost dominating critical minerals especially. So it's all rare earth, it's all about China, graphite, and they are well ahead. It is basically due to the applications of R&D in the exploration area. So here also they have dominated all upstream, midstream, downstream, starting from the mining, processing, battery metal, battery cell pack, EV development. We can see it's all about the success story of China. Here, then extractions also and processing also, they dominated in a very large way. So this nanotechnology or nanogeosciences is useful both for the identifications of the prospects and the recovery also very important, because here we do study on a nanoscale, we try to find out mineralizations. It's all about the high-end characterizations of the minerals, and if you know in what oxidation state the different elements are there, we can develop and we can give them to mineral engineers, they can develop better flow sheet for the recovery. So what I think, the recovery is a major challenge than the explorations of these critical minerals, especially where the metals occur in trace amount. 1000 ppm, below 1000 ppm, we are saying it's a trace elements, and SOR, RE, trace element, including gold, they occur in very trace amounts. So that's, they got successful by the applications of this branch of geoscience. And now you see the status quo of Indian exploration history. This is an old data, Indian Bureau of Mines, 2011. We can see no domestic reserves, cobalt, very poor reserves, boron, copper, lead. There are not explored well. So situation has more or less not improved much. We still don't have the huge reserves of nickel, cobalt, and other critical minerals. So there are various issues. Apart from the explorations, we have the recovery issue, both primary, from primary deposits there are recovery issues, from secondary deposit there are recovery issues, because we are now thinking of extracting from the tailings dams, waste and all this. So the situation is not quite encouraging. So what should we look upon? Yes, as I said, the exploration is wonderfully done by our exploration agency, but then here we have to come, academia has to contribute, R&D has to be there, because it's an era of difficult explorations, means we have to go deeper. We have to work on difficult mode of characterizations, we call it the refractory characterization, refractory mineral characterization, where the processing is very, very difficult. So the identifications as well as recovery of metal, non-metal from such old deposits are extremely challenging. So major challenges, the identifications and recovery of valuable critical minerals and the comprehensive characterization. So it is going to help both an exploration geologist, a mineral engineers to solve their processes. And the opportunities are there. We all know very favorable geological setting. Still we have explored 10% or 15% of the obvious geological potential of our area. We have the arrival of advanced analytical technology, FECA, PMA, LAIC, PMA. So it's basically the in situ analysis we are stressing on, because we are mostly concerned with the whole rock analysis. So in situ analysis is the key to the high-end characterization, and it is key to the identification as well as recovery of all those critical metals and non-metals. Another area we are very much blessed with, that's the arrival of interdisciplinary cyber-physical system, that is technology, which has redefined the role of academia as the world-class talent pool. In this domain, we have a huge pool of young force in the IT sectors. They can be used effectively to bridge the technology gap in mineral exploration. So this technology is going to generate a lot of data, and those data can be processed by the arriving technique like artificial intelligence, machine learning, which are going to have a revolutionary impacts on the exploration industry. Already GSI is going to establish a digital center at Bangalore also. So different initiatives are being taken up, and the ministry is also very much positive about the fundings and initiative being taken up at various levels. So this is what I am talking about. If you see the regional scale explorations or deposit scale, we have geophysical prospecting, mapping, remote sensing. Coming to petrographic studies, we are doing micrometer scale. We are very excellent in that area, but what I am talking about is nanogeoscience scale, from the 10 to the power minus 9 meter to 10 to the power minus 7. And then we will also go to the atomic scale, because that processes which are operating. Why this study is important? Because processes which are operating at nanoscale, they are only getting manifested in the regional scale. So his huge deposits, they have very strong connections with the processes, geological processes which are taking up at nanoscale or atomic scale. So these are the analytical techniques, which includes the bulk analysis, for dock I was talking about, XRF, XRD, then micrometers, already we are doing that, and this nanoscale investigations we are more interested about. The different color represents the work being, the data being provided by all those technology. It may be in the form of elemental compositions, structural compositions, surface area in analysis, and then SEM and TEM. It gives you a lot of idea. Atomic tomography, so they all give you the idea on a nanoscale. These are the x-axis represents the scale on which they operate, and that is the detection limit. So now it is possible to detect up to ppb part per billion of the element. So what I say is the in situ analysis is the key to. So in situ analysis is the key to mineral explorations. This is one example of gold, where the free milling golds, they are micrometer size, then colloidal particles, and this one is the nanometer gold, so it is a solid solution, colloidal and micrometer size gold with different techniques. And that technique has helped us in discovering a very important type of deposits, garnet type deposits. Nano size gold, we are calling it invisible because it is very difficult to identify them with the scanning electron microscope. So this is the 70% of the US and 10th largest. This one. Those deposits we call the nano ore deposits, garnet type ore deposits, where the metals are basically within the sulfides, within the pyrites and all those. The methods are called nano prospecting. This is very important. As we see, there was a gold rush in USA, 1849. So that was a time when cyanidation process was discovered, and then there was a huge rush. But then you see, 1985 onward, it was the arrival of nanotechnology. This garnet type was discovered, and we have a huge boom on exploration. So, as we see after the discovery of garnet type, whether pyrite is the key to the gold explorations. So these are some of the pyrites we have studied. In this area only, not mobile grids, these are the pyrite, these are the LASFMS data. You can see they host many trace elements. Here the data is for gold and arsenic. They also hold this one, nickel, cobalt. So these sulfides are also the important prospects which can be worked upon to find out all those critical minerals. And yes, now I'll come to one. These sulfides are also within the coal deposits also. So within the coal deposits, you can see the carbonaceous shale, siltstone. They are very important post rock as far as those critical metals are concerned. So if you can see here, the igneous bodies, dolerite dikes, they are important for RE, we already know. But all those shales and those carbonaceous siltstone, you can say more than 200 ppm. So they are also going to be a very important prospect, and they need to work upon that one. You see this one, igneous, we get RE, apart from igneous, it is the carbonaceous shale and the siltstone, which are the major post rock of those RE, which needs to be looked upon for. So key domains of nanogeoscience, very high resolution for studying sulfur at the nanoscale, understanding nanoscale incorporations of trace element, because all those critical metals are in trace amount only. Colloidal transport is also important for super thin settings. We all know lithium within the bauxites we are getting, it is all about the super thin settings, so those need to be studied. And then atomic and nanoscale processes on more stability also. so that we can understand the mechanism at the atomic scales also. So it has its relevance simply because all the processes operating at nanoscales, they have their implications on the forming processes. We can decode the nature of the fluids, the compositions of the fluids, transportation mechanisms. They are all important to know so that we can understand the whole system to get idea about the process. Now, if you see the India, we are still lagging behind in terms of another major economy, mineral industry has boomed. We are only spending 25 million annually. It has increased now because the limit is there, and we are trying to increase that. But still, we are far behind as far as the spending is concerned. The steps are being taken by the government also. Niti Aayog, in its strategy for New India, they have decided to double up the explored area from 10% up to 20%, accelerating the growth of the mining sector from the current rate of 3% to 14% with an average rate of 8.5 during 2018 and 23. So, increasing job in this area is also one of the area. So, now to achieve the objective to becoming 5 trillion economy, by 2029, India needs to sustain a GDP growth of 8%. We still contribute 2%, means mining industry. So reduction in import of minerals and metal is the key to becoming a 5 trillion economy. So we have a huge role to play means mineral industry if you want to become the $5 trillion economy by 2029. Now there are another also international energy agencies. There are 60 recommendations for the comprehensive approach to mineral security to promote technology innovations at all along the value chain. So apart from nano-geoscience, the data which we will be getting needs to be processed also, and for that there are initiatives being taken by the Government of India. 25 technological innovation hub has been set up at ISM and also we call it TechSpeed. The whole objective is to cyber physical system, applications of cyber physical system in IT sectors to this industry. So its objective is to make India a leading player in cyber physical system, artificial intelligence, blockchain, machine language, drones, robotics. So achieve transportation of shipless technology and explorations and mining for socio-economic growth and commercial use. And so that produce next generation technocrat for developing serious technology in explorations and mining, and their implications to make India mines more innovative, safe and sustainable. So finally, I conclude my topic that mineral resources, especially critical minerals, are essential for technology, including green energy, defense and communications, but our nation is dependent on sources that may have the supply risk, potential supply chain disruptions. Identifying of the sources of these minerals and the chemical and physical processes responsible for their concentrations. To know them is the primary objective for the mineral resource program. That's why the exploration is now being done on ore system modeling. Advancements in analytical technology beyond non-traditional stable isotope have presented the opportunity to focus on specific analytical methods to develop and applications of high-precision trace element measurements by laser ablations and other analytical technologies. Finally, to make significant strides toward this goal, traditional tools must be coupled with innovative applied research, technology, and methodology. So as I said, the exploration success throughout the world is punctuated by the arrival of newer technology. It is our responsibility to empower our young geologists who are less than none with this technology so that we can have the target as set by the Government of India to be $5 trillion by 2029. Thank you so much for your attention. Thanks to one and all.
Professor Singh highlighted the critical role of nanogeoscience in advancing mineral exploration, emphasizing innovation in overcoming the challenges India faces in this sector. Truly a forward-looking approach for the industry. Thank you very much, sir. Now we are taking a short break of 15 minutes for high tea. Please proceed for tea and get refreshed for our next intriguing topics. We have arranged high tea just outside the auditorium. Please reconvene here after 15 minutes.